A common application for the logic node is to act as a filter. So I can create exceptions for values, or I can, for example, keep values within certain ranges. Here I was using constant nodes, and constant nodes are very predictable. I can use the input spy to check what's their value. It's usually just a single value, but most of the times I'm using data that comes from the scene or from image files, and so it's a lot of samples. It's a lot of values that I couldn't check numerically, all of them. So many times I have to, since I'm working in a way blindfolded, I have to create blind rules that applies to those data streams, and basically setups rules that guarantee me that the data doesn't go out of bound or behaves in a way that I don't want. So I'm going to check that here with the logic node using this object called 20 meters box. It's basically a box with a lot of divisions on the x-axis, and I'm going into its displacement node editor. Make sure you have Studio Live on, and I'm splitting the object spot into the scalar components, and I'm just going to use the x value. I'm distributing this value with a vector node just for the blue lines, and there's no technical reason to use this other than I wanted blue lines, so this was not, I wouldn't have a green spaghetti here. So let me know if that's problematic. So this value is being distributed, and it comes here to this compound called pass, and basically this compound is going to apply that value in two ways. Let me put this back into texture solid. So the first one is going to just create to show as a limit, and so if I plug this in here, you can see that I have a limit on the x-axis. The other way it can display is as a graph. So I have now this like a line in the graph where I have positions on the x-axis and on the y-axis. So on the x-axis I have my input, so basically the value that I had here, and on the y-axis I have the result of my filtering, whatever I've done with the logic node. And so it looks the same limit that I've done, that looks like this. The graph version looks like this. So first thing I want to do is actually check for a single case. Let's say that I'm doing a division, and I want to avoid cases where I divide by 0. So I want to check my data stream for zeros and basically replace them with something else. So I have a data stream of many possible values, and I'm going to check them against a single value, and in this case see if it's equal to that value. So if it's actually right on that value, right on the money. So in this case, I'm just going to plug this into this logic node and check if it's equal to 0. If it's equal to 0, I want it to become 1. Otherwise, I want to pass whatever I had before. So if you look here, what's going to happen when I plug this is that these vertices are going to come up. Well, I'm in the graph mode. So what happened is that these values, these vertices had a position on the position X, they had 0. So now instead of 0, they have 1. So when I put this here, what's going to happen is, well, they're coming up by 1 unit. Of course, if I change this to say 0.5, they get here. But what matters is that I weeded out zeros. I don't have any 0 coming out of this logic node, and sometimes that's important. So instead of using equal, I can also use less than or greater than to create not just a single value exception, but create an exception for values that are to the left or to the right of that value. So I can create rules not just for a value that is equal to, but values that are less than or values that are greater than. So with this, I can check here, I'm going to check if my mesh X position values are less than my object A X position value. And so if they are less than my object A, I'm going to have them have the position that object A has. Otherwise, they're going to have the same position they had. So it looks like this. Basically, I limited values that are to the left of A, created a lower limit. If I change this to greater than, then I create an upper limit. I do not let the values go beyond above this value. Okay, so there's another way to create this lower and upper limit by using the minimum and the maximum nodes. So if I just plug in the value and the object A position here in the minimum, what I'm going to get is I'm going to get an upper limit. So since I'm retrieving the values that are the minimum, what's going to happen is that I have my values. I have, in this case, my object A. So up to this point, the mesh had, it was the least, it was the most, the values that were, had the least amount. So those are kept. When the mesh crosses over A, what's going to happen? Well, these values are all going to be greater than A. So what's going to happen? Well, they're going to be assigned the value of A. So I'm going to create an upper limit with minimum and the lower limit with maximum. This is not very intuitive at times, but keep in mind that most of the times you are not looking at things like this. We're just doing these, blindfolded. We just have to try a lot of things that I demo here. I pre-prepared them, but most of the times I just try one thing that doesn't work. Let's try something else, etc. So don't worry too much about keeping these things. So I can create these one-sided limits with minimum and maximum. What if I want to create two limits? So what if I want to have a lower limit and an upper limit? Well, the go-to node is the clamp node. I can have here this object B as well, so B, and I'm going to use it to be my high limit, and A is going to be my low limit. So I have the value, low limit, high limit, and when I plug here the clamp, you can see it looks like this. But there's an issue with the clamp. I can, even though, for example, I can replicate it with two logic nodes. So since I'm checking for two limits, it's just a case of stacking another logic node, as you can see here, and it's going to do the same as the clamp. But there's an issue with this implementation, is that, let me put this into the graph mode. When the low value crosses to the right of the high, this is going to happen. So this is not very good, right? Because now I don't keep anything of what I had. So I had these values and I clamp them. And when when the low value crosses the high one, I keep none of them. I just keep the values of the limits. So what can I do to fix this? Well, I can clamp them, but instead of using them straight away, I can check for which of these two values, which of them is the minimum, and then I use that on the low, and then I check for which one is the maximum, and I use that on the high. So by doing that, I assure that the value that is on the low is always the minimum, and the value that is on the high is always the maximum of the both. So this way, when they cross, you see there's a swap, right? So when I have A to the left, you can see that I have minus 2.5 and minus 2.5 coming out of here. B is 1.9. So when I put this to the right of B, this becomes 1.9. So the minimum, B becomes the minimum. So there's a swap between low and high values. And so this makes this work. If I want to do this without having to rely on tree nodes, I can do it with a remap node, for example. And so I can, for example, let's see, I can put A on in minimum and out minimum. I can put B on in maximum and out maximum. And I just have to make sure that the clamp values is selected. So when I plug this in, you see that it works. It works the same. It's a bit annoying having to do all these connections, but at least it's just one node. Okay, let me check one last case. So I've done a rule where I have two limits. I have a min and I have a max. And so in here, the values that I'm keeping are the ones that are in between those two limits. So in this case, I kept the values that are in here. And the ones that are outside this range, they were changed, they were made constant. What if I want to do the other way around? Let's say that I want to keep these values and I want to make these in the middle constant, just an exercise. Well, I can use this logic node. So I can do two comparisons, and then with those two comparisons, they're going to generate a Boolean, and I can mix those Booleans so I can achieve that. So instead of having the slope in the middle, I'm going to have the slope outside, and in the middle, I'm going to have a constant value. So let's check that. So I have A and B, and I'm going to check which of them is the minimum and which of them is the maximum. And then I'm going to compare my value, and I'm going to check if it's less than my minimum, and I'm going to check if it's greater than my maximum. And so let me just draw that. And so basically the same thing I had in there. I have min, I have max. And so of course values that are greater. So the first comparison is I'm going to compare if my values are less than the minimum. And of course values that are to the left are going to be true, and values that are to the right are going to be false. And in this other comparison, I'm going to check if my values are greater than my max. So values to the right of max are obviously going to be greater than it, but values to the left are going to be true, and values that are to the left are going to be less than, so it's false. So I'm going to combine these two booleans. If I have these by areas, I have let's say false, false, true, and with the other comparison I have true, false, false. So the area that I want to, in a way, to isolate or concentrate in is this area in the middle. So the case that it's going to give me that of the combination of the two booleans is when they both are false. So false, false is the rule that I want to get this to become true and this one to become false. Okay, so let's check that. So here I set up false, false. So when this is false, false, I want this to be constant. Let's say I want it to be, let's say, 2. Otherwise, the ones that are false, I want to keep them as they were. So when I plug this in here now, you can see that outside of that range, they kept that slope they had, but in between, it's just a constant value. So of course I can change this, let's say, to 0 or to 1, etc. But I just basically, in a way, inverted the mask that I had here. So that's it. It's several ways to basically limit your range of values. Having range control, over a stream of data is very important. And so these are some examples of it.